So the next concept is state tables and graphs. So far in the previous sessions, in the previous concepts or previous chapters, so as we analyzed some of the circuits which are smaller circuit, in case we can tell it is a smaller circuit, it was easy to analyze the things. Okay, though the size of the circuit is smaller, it was easy to analyze what is the input equation, what is the output, the things we could have done easy. We did it easily because the size of the circuit was less. But actually the real thing is the circuits will be not that small. So when it gets bigger and bigger, it's not easy to analyze the circuit. Okay, so to determine the input equation as well as output equation, it's not possible. So as the size of the circuit keep on getting bigger, so in order to overcome that problem, if you want to analyze the circuit which is of a bigger size, we need to have a concepts like state tables and graphs. Okay, so this is what we call it as a the transition table. This is what we call the state table, and the graph, this is what we call as a graph. Okay, so by using this graph we can able to easily analyze how the circuit works, what is the input equation, what is the output equation, how the circuit switches from one state to another state, like that. Okay, so that is why we came across the concepts like state tables and graphs. Okay, so in order to construct a transition table and state table, following things need to be taken into consideration. First, determine the flip-flop input equations. So we need to determine what is the input equation for the flip-flop. Okay, as you all know that each and every circuit will containing the flip-flops. So what is the input for that flip-flop? What is the input equation? That is the first thing. And output equation. That's the first point. So the next point is determine the next state equation of each flip-flop. If the circuit is made up of D flip-flop or JK or SR or T flip-flop, we need to determine the next state equations. So we all know that what is the next state equation of D flip-flop, that is Q plus is equal to D. If it is clock enabled, this is the equation. This is for T flip-flop, this is for SR flip-flop, this is for JK flip-flop. These are the characteristic equations of the different flip-flops. So we can also say that this is next state equations. Okay, next state equations, this is the second point. So plot the next state map for each flip-flop. If the present state is this, what would be the next state? So we need to plot the graph, that's the next state map. Okay, combine these maps to form a transition table, such as once the transition table is done, we can easily able to identify what is the next state based on the present state. So these are following 4 points which we need to follow through in order to determine the state tables or transition table, or to construct a graph as well. Okay, so let me take an example. Like here we have taken a simple circuit, figure number 13.5. Where is the figure? So this is the figure 13.5. Keeping this circuit diagram in mind, they have constructed a state table, transition table, and a graph as well. Okay, so first look at this, the flip-flop input equations and output equation. What is the first thing is we need to determine what is the input equation and what is the output equation. So look at this. So this is an input, DA is a one input and DB is the one input. We need to determine what is the input for DA, this input, and what is input. So look at the input for DA, X. This can be written as X or B bar. This is an input equation, A plus X. So this is for DB and this is for DA. This is for DA, this is for DB. These are the input equations for this is DB and DA. So what is the input equation for Z? One is from B, another from B. A X or B is an input equation for Z. Okay, so that's what they have written. See, DA is equal to X B and X plus A and Z A plus B. So these are the input equations for DA, DB and Z. Okay, what is the next state equations for this flip-flop? So what is the next state equation means? So what is the next state? We normally represent next state as A plus, here B plus, right? If you want to determine A plus, we need to have for this input. Based on the input, we are going to define A plus. Before the input, we are going to determine B plus. So that is what they have written. A plus is equal to X XNOR B bar. This is X plus A, X OR get A. What is the same thing? So based on the input for X and based on the input for A, we determine B plus. Based on input for B bar and based on input for X, we determine A plus. This is the next state equations for flip-flops. Okay. So corresponding maps. So what happens if I am going to pass the value a? First you just we have two inputs dA and dB. So we need to determine the two outputs. That's the output equation a plus and b plus. So two k maps have three variable k map. So as usual 0 0 0 1 1 1 1 0 0 1 0 0 0 1 1 1 0 1 0 1 0 0 1. Okay, a b and x. Okay, so what is this? A b is equal to 0 0, x is equal to 0. If the x value is 0, if the AB is 0 and 0, what is this? We need to determine. So look at it. What is that? X value is 0. This is also 0. A is also 0. B is also 0, but here it is B bar, so it will be 1. So 0 and 1 in case of XOR gate, XOR gate is 1. So 0 and 0 in case of OR gate is 0. If I am passing 0, the B plus will be also 0. And this, if I am passing 1, the A plus will be equal to 1. So we got A plus, that is 1. We got B plus, that is 0. So this is A plus. If A is 0, B is 0 and X is 0, A plus is 1. See, A plus is 1. And A is 0, B is 0 and X is 0. What is B plus? B plus is 0. If I am passing 0, you are going to get a B plus is 0. So I have written 0. Similarly, what happens when A is equal to 0, B is equal to 0, X is equal to 1? What happens when A is equal to 0, B is equal to 1 and X is equal to 1? So similarly, input, if you just keep on passing the values respect to A value, B value and X value with respect to that particular circuit and analyze the things and fill up these k maps, you get these values. Once you are done with this, okay, you need to write the state table. This is a transition table, this is a state table. Okay, look at this. When AB is 0 and 0, when X is 0, what is A plus and B plus? AB is 0 and 0. This is 0 and 0 and this is 0 and 0. This is 0, 0 and 0, 0. Both AB is 0. X is equal to 0. X is 0. What is A plus? What is B plus? A plus is 1, B plus is 0. That is what they are, 1, 0. If AB is equal to 0, 1, X is equal to 1, here it is, X is equal to 1, X is 0 here, here X is equal to 1, AB is equal to 0, 1, X is equal to 1. What is A plus? What is B plus? A plus is 1, B plus is 1. That is what they are. Let me explain one more thing. If AB is equal to 1, 0, here it is 1, 0. X is equal to 0, X is equal to 0. AB is 1, 1, 0. X is, if you want to write A plus, you check here. If you want to write B plus, check here. So when AB is 1 and 0, AB is 1 and 0, X is equal to 0, X is equal to 0. What is A plus? What is B plus? A plus is 1 and B plus is 1. They are written 1. Z is randomly taken 0, 1, 0, 1. Okay. Okay. This is how you are supposed to write the transition table. Based on this transition table, you are supposed to write the state tables. As we all know, 0, 0, 0, 1, 1, 0, 1, 1. This is what we call it as S0, S1, S2, S3. So right now 0, 0 means S0, 0, 1 means S1, 1, 1 means S2, 1, 0 means S3. Okay. When the present state is 0, 0, if you are going to pass X is equal to 0, it is going to move to 1, 0. 1, 0 means S3. 1, 0 means, okay, 1, 0, right? Okay, I wrote 0, 0, 0, 1, 1, 1, 1, 0. Okay, S3. So then, if I am going to pass X is equal to 1 value, it is going to move from 0, 0 to 0, 1. What is 0, 1? S1. Right, S1. S3. Right now, let me take S3. 1, 0 S3. If I am pass X is equal to 0, it is going to 1, 1. That is nothing but S2. I have written S2. If I am passing 1, it is going to 0, 1. 0, 1 is S1. So S1. So this is how the transition table has to be written. This is how the state table has to be written. Based on these two, we are going to just plot the graph. So look at this. This is S0. This is S1. S2, S3. S0 means 0 0, this is 0 1, this is 1 1, this is 1 0. Right. You can notice here 0 1 0 1. These all values are written from Z 0 1 0 1. Okay. So right now we are in the S0 state. This 1, when if the x value is 1, right now we are in the S0 state, that is 0 0. If the x value is 1, right now we are in the S0 state. If x value is 0, x value is 1, this will move to S1 state. That is what they are, S1 state.